over, see how it gets darker green, and now you can be heard.
Okay.
So when it gets dark green, you're on. And so when he goes and you're done.
Okay, thank you.
Can I test out the...
Yes. Okay, can everyone hear me pretty well? Good? All right. Yeah, I think we'll get started. So we've noticed that there's been some issues with just people maybe not necessarily having a lot of familiarity with Python or some other libraries that we're going to use in this class. So today we just want to sort of give an overview and a little tutorial of some useful concepts and also just give an intro to Python. I aim to start sort of slow for those of you who have never used Python before, so bear with me in the beginning and then we'll go into more topics about object-oriented programming and classes in Python, and then we'll finish off by going over NumPy and matplotlib. So yeah, and feel free to stop me at any point if you have questions or concerns. So yeah, let's just start with some basic Python demos. So Python is an interpreted language, which means unlike C, for example, which is compiled, you don't have to compile your code when you're attempting to run it specific to your machine. There's something called a Python interpreter, which basically takes your Python file and interprets the code as it goes along. So yeah, let's start with some basic syntactical things. So typically, when you want to define a function in Python, we're going to use the keyword def, and you're going to give a function name. So I'm going to define a very simple function here. It's going to be the sigmoid function. It's going to take an input x. Yeah, do we have a question? On the left one? Yeah. How's that? Is that okay? Or more?
Is it turning the light off?
Yeah. How do we turn this light off?
I don't know. Try and press whatever will turn all of them off, which we don't want.
It's probably this guy.
This one. Dimmer. Let's see. Is it dimmer? Looks like the lights are going down. Is that okay? Okay, there we go. All right. Yeah, so we're just going to start off by defining, just going through how we actually define functions in Python. So it's pretty straightforward. You use the keyword def. Def means you're about to define a function. And after def, you have the function name, and then you're going to give the function all of its inputs. So here we're going to define a simple function, the sigmoid function, which I defined here. So one way we can do that is, so for this function, for example, we can simply just return the value pretty easily. Before I do that, I'm going to import a library. Now, libraries in Python, there's a lot of built-in libraries. For example, the library I'm about to import, which is called math. And the way we import libraries in Python is use the keyword import. So once I import math, I can now use all of the methods that this class, this library class provides to me in Python. So for example, here, if I'm trying to create the sigmoid function, what I'm going to do is simply, so I'm going to use the built-in exponent function in the math library. And what this does is just allows us to do e to the power of something you provide. So here I'm going to provide it -x. And yeah, this is a simple way to define a function. We can also try running this right now. Let me just save the file. So how many of you have used terminals before? Okay, so a decent amount of you. So for those of you who have no familiarity with terminals, essentially a terminal gives you something called a shell, which allows you to run programs as a user. So for example, if we have a terminal open, I can invoke the Python interpreter by just typing in Python or Python 3 if you're using Python 3. And what that will give me is a Python interpreter. Now, what that means is now I can try out like simple things, like for example, if I want to create like a simple list, I can do so. I can also run Python files. For example, this file is called practice.py. It's in the same directory that I currently invoked the interpreter in. So I can import this file by saying import practice. You don't include the .py when you're importing. Now I have access to all of the code that I've written inside of this file. So now I can invoke the sigmoid function. So let's just try -10. Oops. There we go. So forgot to mention that when we're actually importing files, if I want to import everything inside of this file that I've just defined, so practice.py, what we want to do is actually say from practice import star. What this will do is it'll import everything we've defined inside of the file. Otherwise, I can import specific functions like I just did here when I said from practice import sigmoid. So this is the type of syntax you want to use when you're importing files. Okay, so let's move on. So I think you guys are going to have to use probably the random library a lot in your homeworks. So just briefly, let's talk about random. So random is just a library that gives you a lot of random function capabilities. For example, let's just import random here in the interpreter. So one example function is random.uniform. That will give you a uniform random number between the bounds that you defined. Another useful one is random.random. And what this will do is it will give you a random float between 0 and 1. And every time you invoke it, it's going to be just a different random number. Now, one very important thing that will help you debug your code when you're using randomness is something called a seed. So you can essentially seed the random number generator inside of your code. So for example here, let's say I had a lot of randomness that was occurring in my code. To help me debug, to avoid basically every time that I rerun this file, I'm going to get a whole different sequence of numbers. What I can do after I import the random library is essentially seed my randomness. So I can choose any integer, let's just say 0 for the sake of argument. And essentially now what's going to happen is every time I rerun this file, I'm going to get the same random sequence that I did before. So now it'll help me debug a lot better. That's just one quick tip. So yeah, now let's go through some of the Python data types. Let me just clear this. So in Python, you have a variety of data types. Most of you will probably be familiar with these data types from other languages, but there's two important things to note about Python is there's a notion of mutable and immutable data types. Now, mutable data types are, they're sort of how they sound. You can essentially change their value, or you can change their, you can modify them, basically. Python will let you modify them. If they're immutable, Python will not let you modify the object directly. For example, strings are one example of a Python data type. Let's say we define a string s. Now, if I try to modify s, for example, if I try and change the first character in s, which is capital C, to, let's say, A, Python will give me an error. It's going to say, stir object does not support item assignment. So once again, this is because strings are immutable. You cannot modify the string in place. So if I wanted to define a new string, for example, let's call it L, and I wanted to change the first character, then what I could do is say L equals A plus S. So let's just quickly go over this notation. So what I'm doing here is, first I'm saying I want the first character of the string to be capital A, and I want you to concatenate this capital A with every character in the string S, starting from the first index all the way to the end. So now if we see, we've changed the string. So this type of notation is used for a lot of different Python data types. For example, we can use it in strings. You can index strings. You can also use it in lists. So for example, let's move on to the next data type. Let's define a list, L. Let's just put some simple numbers in it. So here's our list, L. So once again, what you can do is you can index through the list. So for example, if I want only the elements in this list from the first index on, I can do this. If I want only the elements in this list that are starting from the first index all the way. So essentially, let's say I want to take all of the elements in this list except the very last element. So what I can do is something like this. Now let's just go over this real quick. So these bounds that you're defining when you're indexing, it's inclusive of the first bound and exclusive of the second bound. So what that means is whatever I define here is going to be included in what I'm indexing, and whatever I define after the colon is going to be excluded. So this is an exclusive right bound. Okay? So lists are mutable. So what that means, I can change the entries inside of the list. So for example, if I want to change the element in the first index in the list, the 0th index, to, let's say, 5, then I can do that. I can also mix and match different types of data inside of the list. For example, right now this list only has integers inside of it, but if I wanted to, I could mix strings in here as well. So let's say I want to change the first element in the list to a string. I can do that. So I can mix and match data types inside of my list, unlike other languages. That doesn't let you do that. So, okay, let me clear this again. So I think one thing that's been giving some people trouble is list pointers in Python. So what I mean by that, let's say we define a list L, and I'm going to define another list. Well, let's call it L0, just to make it easier. Okay, so here we have our first list L0. Let's say I do something like the following. I say L1 equals L0. So here's L1, and here's L0 again. They have the same elements inside of them, right? Now, what happens if I say L1 of 0 equals, oops. So what do you think is going to happen to L1? It's going to look like this, right? What is L0 going to look like? 1, 2, 3? No, right? What we've just done is also modified L0. Because when we made the assignment L1 equals 0, we are not creating a new copy of L0 and setting it equal to L1. We are physically saying L1 now points to the same list that L0 is pointing to. Okay? So we have to be careful when doing this, because if you modify L1, you're also modifying L0. Now, one way we can avoid this is we can say L1 equals L0 dot copy. Oops, hold on. Sorry. Okay. Sorry, I think I forgot. You can do list.copy, right? I think I forgot the syntax for the...
I think the easiest way is just do list with other list.
Sorry?
You use constructor.
Oh, okay, I see. Okay, before we do that, though, let's talk about one more thing. So I said how doing this essentially tells L1 to point to the same list as L0. Now, one other notable difference in Python is what if we say L1 equals L0 plus another element? So now L1 looks like this, right? What if we now modify, so this is L1, this is L0 now, right? So initially, I've done this similar thing to what I did before by setting L1 equal to L0, but now I've added this, okay? So now what if I modify the first index, the first element inside of L1 to, hello. So this is L1, right? What is L0 going to be? So L0 is unchanged. Now, why is this? This is because when you do something along the lines of a list equals some original list plus another list, you're actually creating a whole new copy with the elements that you're defining. So that is one way to create a new copy of a list. Now, okay. Another issue is, let's say we have a 2D list. So here's our list L. Okay. Now, let's set this first import copy. Okay. So one thing you want to make sure you do with any lists that contain also mutable data types inside of them, especially if it's a list or a dictionary, if you want to make a copy of this list, one very useful function is, first, it's inside of the copy library, so you first want to do import copy. What you can do is you can say copy.deepCopy of L. So what I just did is S now is equivalent to L. However, what deep copy is doing is it's actually doing a recursive copy. So it goes into each element inside of L and then recurses again inside of that element and keeps doing that until it hits, till it essentially hits the integer itself. So it's going to copy the list in a way that no matter what you do to S, it will not affect L. So for example, if I take the first, so let's first take the first element of S, which is this list right here, right? If I say test of 0 now equals this. So here's S, and here's L. It's unchanged. Okay? So now let's go through dictionaries real quick. So the way you define a dictionary in Python is you can use the curly brace notation. So a dictionary is essentially sort of a hash map. So basically how it works is you can provide keys to the dictionary and map them to elements. Yeah, do we have a question?
Oh, yeah, it was about list copying.
Yeah.
If you did like L1 equals open bracket x for x in L0 close bracket, is that the same as making a copy or is that different?
Sorry, say that again, the X part?
List comprehension, you did like L1 equals
So let me define a list. Is it a 1D or 2D list that you're talking about?
I guess my question would apply to both.
Okay, so let's say we have a 1D list like this. And then what are we doing?
Open bracket with x for x in L0.
X for x in L0.
And like, is that equivalent to the copy function
I see. Let's try it.
or not?
Yes, it is. Yeah, so in general, I a lot of times when I'm using Python, this is just one tip. A lot of times when I'm using Python, there's just so much in the Python library available to you. You're not going to remember everything you learn about Python. One very useful thing is I always like to have an interpreter open for me to try out things like this, especially if you're doing more complex programming, and that's relying on lists. If I forget like a simple rule in Python, I like to try it out first just to make sure. Also, Google is your friend. There's a vast amount of documentation on Python online. So yeah, okay, let's get back to dictionaries though. So we defined a dictionary D. So again, D, you can map essentially keys to elements inside of the dictionary. Now, one thing about Python is the keys of the dictionary have to be immutable. As in, I can use strings as keys, I can use integers, I can use floats. I cannot use lists as a key. For example, let's say I try to assign the list, let's say I give the dictionary a key, which is a list that has the elements 1 and 2, and I want to say map this to a string. Python is going to give me an error. It's going to say unhashable type list. So we cannot use mutable data types as keys for the dictionary. Now, here's our dictionary D. Let's say we want to map the string 0 to its integer. Oops, sorry. So now what we've done is we've provided a key, which is the character 0, and mapped it to the integer 0. Also in dictionaries, you can mix and match different data types. For example, I can also do the following. So now I have keys that are both characters or strings and integers. So Python allows you to do this. I think it can be a little weird sometimes, but it's also one of the main powers of this language. Let's see. Is there anything you guys would like to see specifically about dictionaries that confuses you? Otherwise, I'll move on. They're pretty simple data type. Okay. Let's see. So another thing you can define in Python is a set. So again, a set only holds unique elements. So if you try and add an element into a set that already exists, the Python set library will automatically just not modify the set. So if we define a set X, the way you do that is this notation. It's just set with the open parentheses. So now we have a set. So if we do set s dot, I think it's append. If we do s dot append of 0, oops, it's not append. Sorry, do you guys know that? Sorry? Add? Yeah, sorry, s dot add. Yeah, see. Okay, there we go. So if we do s dot add 0, we get 0 in there. If we do s dot add of 1, we get 1. If we try to add 0 again, this set is unmodified. Okay, so do you guys have any questions, for example, about integers or floats in Python? So one thing about Python floats is, for example, what do you guys think is going to be the result of this? Is it going to be a float or an integer? Oh, sorry. So yeah, the result is going to be a float. So in general, if you're mixing and matching integers and floats, it's going to default to a float. However, you want to be careful. Sometimes Python does some weird rounding, has some weird rounding errors. So if you're working with float notation, I would try and stick with floats in all of your operands. Let's see. Okay. Oh, yeah, so one way you can quit out of the Python interpreter is you just invoke the quit function. Okay, so let's see. Do you guys know how to use print statements in Python? Are we comfortable with that, or should we go through that as well? So let's just go through it real quick. So in Python, you can essentially print almost anything. The way you do that is by using the print function. So if I want to print a string that says hello, we can do that. Let's say I even define a dictionary. That's just very simple dictionary D. I can even print the dictionary as such. I can print lists. You can print a whole variety of things. Now, one useful technique to use when printing is you can do essentially something along the lines of this. So what you can do is you can use data type identifiers. So for example, if I'm using %s, that means I'm expecting a string s, a string to be concatenated to what I'm printing. So for example, if I wanted to concatenate a string s right after the hello, I'm going to use the modulus sign and add the string that I want. Okay, now let's say I wanted to add an integer there. You're going to use the %d symbol, and then you provide the integer. Okay, so there's a lot of different symbols you can use to print out different types of data types. Again, I recommend for whatever use you have, just try and look it up online. There's a huge amount of documentation. In general, print statements are very useful when you're debugging or even just trying to see exactly what your program is doing, especially because Python makes it so easy for you to print. I recommend using them whenever you can. Okay, let's see. So there's two different types of loops in Python. There's a for and while loop, just like a lot of other languages. Sometimes the way for loops in Python work might be a little weird for some people, so let's just try and go through that. So let's say I have a list that looks like this. And let's say I want to go through and print every single element in this list. So there's a couple ways we can do this. One way is we can use a built-in Python function called range. Now, what range does is it essentially creates a list from a number range that you provide to it. So for example, let's say here I say range of 10. It's going to give me a list from 0 to 9. So essentially a range of 10, what it's doing is equivalent to doing something like this. So again, the right bound is exclusive, the left bound is inclusive in this case. Oh, sorry, I can't run this. But so if we did this, we'd get the same result. So let's go back to the for loop here on the left. So let's say we want to loop through the list L and print out every element. What I can do is I can say for I in range len of L. So len is a built-in Python function that returns the length of a list. So here the length of the list is 3. So this is essentially going to be for I in range of 3. So what kind of indexes are we going to get here if it's for I in range of 3? 0, 1, 2, right? So now what we can do is we can say print L of I. So what that's going to do, L of I is going to access the ith element of the list L, and print L of I is just going to print it out. So let's just... let me just run this program real quick. So if I run this practice.py file, we can see here we've printed out all the elements inside of the list. So let's look at another way to do this exact same thing. So another thing we can do is we can directly loop through all the elements inside. Yeah, do you have a question?
So I just wanted to point out that in Python 3, the range does not directly produce a list. Like it does in Python 2. Just so people don't get confused.
I see.
Like you can do for x in range
Mm-hmm.
at the beginning of a for loop, but if you try to just say like x equals range 10 and like print x, it won't print a list because it like creates the list on the fly during the for loop.
Mm-hmm. Okay, so you're saying, so I think this will be unchanged, is what you're saying, correct? But it doesn't physically create a list.
Yeah.
Yeah. Okay. Yeah, you're correct. Mm-hmm. Okay. So another way we can go through this list is we can directly loop through the elements of the list. So what I can do is for element in L, print element. So these two loops are going to do the exact same thing. The difference is here we are looping over a list of indices, and here we are looping through the actual elements inside of the list. So these will produce the same exact results. Any questions on for loops? No? Okay. So now while loops. So the way you define a while loop in Python is you just do while, use the keyword while. So while loops are going to keep looping until something called a loop guard, which is what you define inside of the while loop, is not satisfied. So for example, if I say while true, this is going to be essentially an infinite while loop unless I break out of the loop somewhere inside, because the loop guard is always satisfied. This is always going to be true, so we're always going to be looping. If I say, for example, I equals 0, and let's say I equals 5, while I greater than 0, and then I'm going to say print I minus equal 1. So what is this going to do? How many times are we going to loop here? So we're going to loop 5 times, right? So essentially what's happening here is we initialized I to 5. We check to see if 5 is greater than 0. We're going to print it out, and every time we're decrementing I by 1. And by the time I hits 0, once I becomes 0, it's no longer greater than 0, which means we're going to exit the while loop. Now, let's say we wanted to do this a different way. Sorry. Let's still keep I equals 5. So now we've done a while true. So if I run this code right now, this is not going to terminate, right? We can also try that. Let's put some print statements in here. So this is going to keep looping until my computer crashes or runs out of battery. So some tricks we can do in Python is there's 2 types of statements. There's a break statement and a continue statement. So let's just go through basically how we can use these 2 different things. So what a break allows you to do is it allows you to break out of a loop, essentially. So one way I can modify this code is by saying if I is less than or equal to 0, break. So now, every time I'm going to decrement I once again, just like before. But now when I actually reach 0, I'm going to break out of this loop. So you can see here we get the same result as before. Now, that's how you use break statements. So how do we use continue statements? So what a continue statement does is essentially it skips over the loop iteration. So putting it at the end is not going to help. So let's do it here. Let's say if I equals 3, continue. So what should we expect to see in the printout when I run this code? So earlier we saw 5, 4, 3, 2, 1. What are we going to see this time? Yeah, so let's check it out. Oops, forgot to break the loop. So one mistake I made there is I left the while true here, so it was infinite looping because I took out the break statement. Wait, this is sorry. Okay. So again, we were infinite looping because I forgot to decrement I by 1 in this case. So what was happening before I had this line is we were decrementing until I became 3. And then we went in here and we hit the continue statement, which would constantly pass all of the code after. So we would never actually execute this code. So again, we were infinite looping. So now this should finally work. Yes, okay. So that's how you can use break and continue statements in Python. Okay. Any questions on this so far?
Yes, for example, you want to do a for loop and get the index as well as the element. How would you do that?
If you want to get the index as well as the element. So you're saying for a list, for example?
Yes.
So let's say we have a list 1, 2, 3. So the index and the element. I mean, there won't be a way to do that, I think, using L directly, just because how would you produce the index and the element itself? Because, do you have a comment on that?
I think I remember there's something like...
Unless there's a built-in, there could be a built-in function, for example, in dictionaries.
Enumerate?
Yeah, enumerate. So, for example, in dictionaries, there's one built-in function you can do, which is d.keys. This will provide you a list of all the keys inside the dictionary, and then you can loop through. There might be something equivalent in L. Again, I'm not exactly sure. I would recommend look that. Usually, what I do is if I'm not sure of something, I'll Google how to loop through indices and elements of a list in Python, and I'm sure something will come up. But yeah, good question. Any other questions? Okay. For the sake of time, let's start going through object-oriented programming in Python. Okay, so now we're going to go through how do you actually use classes in object-oriented programming in Python. So first of all, why do we even want to use classes? So it gives us a way to basically group data logically through the use of functions, which are called methods inside of classes, and also attributes, which we'll talk about in a little bit. Typically, when we're creating classes, we want to create classes with some sort of logical connection or unified functionality. Like the reason we're creating a class is to make our lives easier. Okay, so essentially it's a modeling technique. It's very useful to maintain state in a program, and also sort of define a blueprint for what we're trying to do. So let's look at a quick, simple example. This is an example of a class that's defined in Python. So right away you'll see a few things. You see something called init, which we'll talk about in a little bit. This is the constructor method of the class. And then you see 2 other functions. One is called withdraw and one is called deposit. And all the 3 of these functions take an argument called self, which we'll also talk about. But I just wanted to very quickly give a quick example. So first of all, just because we've written this code does not mean we've instantiated the class. What we've just done is basically just laid out the blueprint for the class. This is what our class definition is. So again, this does not actually create the class. To actually instantiate the class, we have to call the init method, which I will talk about more in a little bit. And when you call the init method, you have to give all of the arguments that the init method takes except self. So for example, in this previous example here, if I want to instantiate this class, I'm going to say Mario equals customer, which is the name of the class here. And I'm going to provide 2 arguments. The first argument is a string, and the second is a float. So if you see here in the init method, it takes 2 arguments. It takes a name, which is a string, and a balance, which is a float. And essentially, just very simply, this class, all it's doing is basically it sets up a bank account for a customer, and you can withdraw and deposit money. So here's the class again. So now, what does self actually mean? So self is essentially the instance of the class that we are using. So basically, when you're defining a function, which is called a method inside of a class, you need to include self as the first argument so that we can actually use all of the attributes and methods that are attached to that instance of the class. So self is a syntactical way of saying, I get to modify and read all of the data attached to the instance of this class. Okay? So for example, this last line that I'm showing here, these are essentially doing equivalent things. So let's say I wanted to withdraw money. So earlier here, I defined an instance of the class customer, and I named it Mario, lowercase. So let's say I wanted to withdraw money from my account. I can do this in one of two ways. I can either do mario.withdraw, which calls the withdraw method inside of the instance of the class called Mario. Or I can do customer, which is the name of the class, dot withdraw, Mario, comma, how much I want to withdraw. So the reason these are equivalent is because when I did customer.withdraw, I still provided the instance of the class that I want to withdraw from. Versus in the first way, I'm using the method of the instance of that class. So I said a lot of words here, so let me know if you guys are confused. Is there any questions on this or clarifications needed? Yeah.
I'm just wondering, you should do it the first way. How can you know that withdrawal belongs to the class customer?
How do you know? I mean, you've defined it, right? You mean, how do we know that Mario has a withdraw method?
I mean, how can you know? So say like you have like customer 1 class and customer 2 class,
Okay.
and then both classes have withdraw. How can you know?
How do you know that we have the withdraw method, basically?
Yeah, how can you know like if that withdrawal belongs to customer 1 and customer
Oh, I mean, so every time you instantiate a class, like I said, let's say I have two instantiations of the customer class, right? Let's say customer 1 and customer 2. So if you want to withdraw from customer 1, you do customer 1.withdraw. If you want to withdraw from customer 2, you do customer 2.withdraw, right? So then you know you're withdrawing from that specific instantiation of the class. Does that make sense?
What if you do Mario and then
Sorry?
say like if Mario is in customer 1 and in customer 2.
No. So here, Mario, if we look back here at the very last line, Mario is just a variable name that I've assigned to the instantiation of the class. So here, when I'm saying Mario equals customer of my name, comma, what my starting balance is, that line setting Mario equal to that, this is just saying the variable name Mario is now set to the instantiation of this class. So now whenever I pass around Mario or use it, I'm referring to this exact instantiation right here, right? So that's how we keep track, essentially, of, yeah. Good question. Any other questions?
So calling draw on the right-hand side,
Mm-hmm.
customer there is not an instance to it.
Sorry?
So we're passing an instant Mario.
Yeah, so,
Customer
yeah.
dot withdraw, but in that case, customer is not an instance.
So, yeah, so that's a good question. So what I'm trying to demonstrate with the last line here is that there's two ways to essentially call the withdraw method. The first way is to use the instance of the class that we defined. We set it equal to the Mario variable, right? Now, if we look back at the method itself, how it's defined, do you see how we have a self argument? Now, I said, again, there's two ways to do this. If you want to do it using the way on the right, you want to basically use the class name customer and do customer.withdraw. You have to provide the instance that you want to withdraw that money from, essentially. Does that make sense? Like if I just did on the right customer.withdraw of 100, how do I know who I'm withdrawing from? Because customer is not instantiating the class. It's not the instantiation of the class. It's just the class definition. It's the name of the class, right?
So in this case, it's similar to importing. Let's say this is not defined as a class.
Okay.
It's similar to import a withdraw function from a customer file, and then we call the withdraw method.
So are you saying, is it implemented as a class in that file?
Yeah, is it similar in that scenario?
I don't think so, based on what I understood from your question.
Okay.
So I don't mean for this to be confusing. I think the best way for you guys to do this is the way on the left. I was just trying to demonstrate what self essentially means. So these are just equivalent ways of doing the same thing, of using the withdraw method. The only difference is, on the left, we are using the instantiation of the class Mario and calling its withdraw method. And on the right, we are using the name of the class, applying the withdraw method, but we still have to tell it which instance we want to withdraw from, which is Mario, right? We just provided the object to this method, which again, that's how we're defined here, right? But if this confuses you, ignore everything I just said and just use the method on the left. Okay. So now, what does the init method do? So we see here, this class has an init method. So essentially, what init is doing is when we call init, we are actually creating the object instance of this class. It's essentially called the class constructor. Now, the way we call the init method of a class is by instantiating the class name with all of the arguments defined in init. So here we have two arguments in init, name, which is a string, and balance, which is a float. So how we actually invoke the init method of a class is by using the class name. Okay? So like, for example, here we're saying Mario equals customer of Mario Sruji, comma 1000. We have just invoked the init method of the class. Okay? We've just constructed the class. We've created an object, which is the instantiation. Okay? Now, any variables defined inside of the init method, for example, here, we see something called self.name equals name, or self.balance equals balance. These variables are something called attributes, and any attributes defined inside of the init method of a class can be accessed inside and outside of that class. Okay? So for example here, again, we have two attributes, self.name and self.balance. If I say, so let's say we first instantiate the class, say Mario equals customer of the two arguments, and then the very last line, let's say we say Mario.name equals Bob. Well, what this will now do is it will modify the previous name we had stored inside of the class to Bob. Okay? Does that make sense? Is that okay? Any questions? Okay. So let's look at, essentially, let's look at this class again. So one thing that I typically like to avoid doing, just to make it more clear to the person who's using or reading my code, especially if they're using my class, is I want to avoid doing something like this. So let's look at what just happened here, what's the difference. So here again, we have two attributes, self.name and self.balance, right? Here we have, we now just removed self.balance from the init method and put it into another method called setBalance, okay? And what we're doing inside of setBalance is we're saying self.balance equals balance. Now, there's nothing necessarily wrong with the way we've defined the class now. The only issue is that there's no way to communicate to the user that there is a balance attribute inside of this class, for example, that we can access something called balance inside of this class, and B, we cannot force the person using this class to call the setBalance function. So, for example, let's say we instantiated this version of the class. What we would have defined is our name attribute, right? Because in order to instantiate this class, we have to call the name of the class, customer, and provide the name argument, which is an init. But we won't have our balance attribute initialized yet until we call the setBalance function. And we have no way of forcing the user to do that. So the best methodology to use, really, when using classes in Python is try and keep all the attributes you want the user to have available to them and for you to have available inside of the class, inside of the init method. Just define it. Okay. So now we're going to go through the two different type of methods that you can define inside of a class. So all of the methods we've been seeing so far are called instance methods because they have the self parameter as an argument. Now, why instance methods are useful is because they have access to all of the data contained in the instance of the object. They can also access and modify anything previously defined on the instance, which is self. Okay? Now, since they use self, they require an instance of the class to be used. That's why we call them instance methods. Okay? So again, all of these methods here are instance methods. So in order to actually use them, we have to provide the instance. That's why before we did Mario.withdraw, not just withdraw. Now, there's another type of method which is called the static method. In static methods, you do not have access to self, A, and you can use it without requiring an instance to be present. So here's a very simple example. Let's say we define a very simple class called car. It has an init method, which has two attributes, the make of the car and the model. So now let's look at the example on the right. Assume we have all the same code as on the left, but now we define this method called makeCarSound. So as you can see here, the makeCarSound function does not have self as an argument. So A, it cannot access any of the data inside of this class. Okay? It cannot modify any of the data inside this class, and you can use this function outside of the class without having an instance. So for example, I can simply do car.makeCarSound, parentheses, and it will print vroom. I don't need to first say Mustang equals car, and then go through that whole process, because this is not an instant method, it's a static method. So I could simply here, instead of saying Mustang equals car and then Mustang.makeCarSound, I can simply do car.makeCarSound and it will print out vroom. Does that make sense?
But if you use that Mustang.makeCarSound, it should print out.
Yeah, it will still do it. Inheritance. Okay. So now let's talk about inheritance. So what is inheritance? Inheritance is basically when you have a child class that derives and inherits data and behavior from a parent class. Okay? Now, the reason we like to use inheritance commonly is it avoids duplication of code. It also allows for the creation of an abstract class, which is sort of a general template. And then you can have children classes that inherit from this abstract class. So let's just go through some examples just to see why this is useful. So let's say, again, we want to define a class that is a car. Okay, let's say we want to give this car certain attributes. We want to give it a certain number of wheels, miles, what sort of make it is, model, year, so on. Okay? So this is how a class would look like, let's say, if you want to define a car. Now let's say we want to define a truck. We could do something like this, right? We can also define a truck class, which also has wheels, miles, make, model, year, so on. So what do you notice between these two classes? They're very similar, right? We've just wrote a whole bunch of code that's doing almost the exact same thing. Actually, the only difference between these two classes is if you see in the purchase price at the very bottom, the car starts off at 8,000, the truck starts off at 10,000. So we have a lot of duplication of code here, right? So how can we avoid that? So one way we can do this is we can define an abstract class. We can define a vehicle class, okay? And what this vehicle class will allow us to do is it's sort of a concept that allows us to embody reusable information, right? So we can basically make the car and truck classes you just saw inherit from the vehicle class instead of just constantly duplicating the same code. So let's look at the example. So let's say we define a vehicle class. Essentially has the same methods and attributes that we just saw. And then we're going to define a method at the very bottom, which is vehicle type. So by doing this, what we can now do is, for example, here's the car and truck example. What we can do is inherit from the vehicle class. See how these classes are taking in an argument called vehicle? So this argument is the vehicle class. What this is saying is the car and truck classes are inheriting from the vehicle class. Okay? So in order to actually instantiate these classes, we need a vehicle class to be present as well. And now what we can do is avoid that duplication of code, because all we have to do is define the vehicle type method inside of these, and we still get access to all of the same methods that the vehicle class gives us, right? So now we've avoided writing so much duplicate code, and we can do the same thing. Okay, now let's look at some simple class demo. Okay, so I've defined some pretty simple classes here. So what I've done is I've defined a pet class. And in order to instantiate this pet class, I want you to give me the name of the pet and the species. And some just very simple methods is you can get the name of the pet, or you can get what type of species it belongs to. And I've also defined two types of pets here. So one is a dog pet, a dog, And as we can see here, it takes in a pet class, which again, here the pet class is the abstract class, and the dog and cat classes that I've defined here are the children. Okay? So let's just look at an example here. Okay, so as we can see here, I've just instantiated the pet class by, again, using the name of the class and providing all of the arguments that we need inside of the init, not including self. So here I provided the two arguments we need, poly and parrot, the two strings. Okay, so now let's see what happens if we print out. So now I want to use the getName method inside of this pet class, okay? So how I'm going to do that again is I'm going to use the variable name that I've assigned my pet instantiation to, dot the name of the method, getName, and what arguments do I provide here? Am I giving any arguments into this method? No, right? Because the only argument getName takes is self, and we don't need to provide self, okay? So that prints out poly. Okay, now, let's say we do something like the following. So first, I'm going to define a pet class again. I'm going to call this pet Mr., and it's going to be from the dog species. Okay? Now, if I want to use the dog class, if we look back here at the dog class, it's inheriting from the pet class, right? So what I'm going to do is, again, I'm just going to give it a name. I'm going to say true, that the dog chases cats. Okay? Now, let's just look at some things here. So, what is instance doing? So, instance is asking us, is Mr. Pet, which is the variable name that I've assigned this instance of the class to. So essentially we're just asking here, is this variable an instance of the class pet? And yes, it is, right? Because right here in this line, we've assigned Mr. Pet to an instantiation of this class, right? Now, if we say, is Mr. Pet an instantiation of the dog class, we're gonna get false, because Mr. Pet is an instantiation of the pet class, but not of the dog class, because it is not even inheriting from the dog class. Now, if we do the same thing for is Mr. Dog an instance of the pet class, we'd get true. Even though Mr. Dog here is referring to an instantiation of the dog class, since the dog class is also inheriting from the pet class, it's an instance of both. Does that make sense? Okay. So, for example here, we can do print Mr. Dog dot. Can we do this? So what I'm doing here is I'm using my instantiation of the dog class, but I'm calling a method inside of the pet class. Can I do this? Yes, right? Because we're inheriting from this class. So I can use all of the methods defined in this class and all of the methods I've defined inside of my class. Okay? Does that make sense? Okay. Are there any questions about classes? Yes?
Is it possible for Python to inherit multiple classes, parent classes?
Sorry, can you say that again?
Is it possible for Python to inherit multiple
Yes.
classes?
Yeah, so his question is, can you have multiple levels of inheritance, basically, right? And the answer is yes, you can. Mm-hmm. Any other questions? Yeah.
There's an identically named method in two classes. One inherits from the other. Is
Yeah.
that override?
Yes, that's a good question. So the question is, if you have two identical methods, one in the abstract class and one in the child class, and inherits from that abstract class, then I believe the child class will overwrite the parent's method. Any other questions? Okay, so I'm going to pass it on now to Jen. He's going to talk about NumPy and matplotlib.
Can you guys hear me? Okay, okay. Oh, okay, cool. Yeah. Sorry about that. Hope it works. Okay, I'll follow up on Mario's tutorial to discuss a little bit about NumPy and matplotlib, which will be hopefully extensively used in the following parts of the machine learning course. So basically, what is the NumPy module? So NumPy is a fundamental package for scientific computing in Python. So this is the official definition of NumPy from their website. But actually, my interpretation of this is NumPy is a module for efficient data and matrix manipulation on CPUs. So why we want to use NumPy in our course, and why we want to use it probably in machine learning related projects. I summarized them into 3 reasons. The first is that it provides us efficient implementation of matrix operations. Basically, you can consider a lot of machine learning models. Basically, we are just doing matrix operations when you want to train the model, when you want to do the inference. Basically, NumPy wrap up like some of the efficient numerical packages from Intel, and it provides us a user-friendly interface to utilize the underlying matrix manipulation functionalities. The second thing is that, as you know, like these days, machine learning is taking the control of a lot of applications, and people are gradually adapting to those standard machine learning and deep learning libraries. For example, the scikit-learn, the PyTorch library, the TensorFlow library. And basically, all these machine learning and deep learning libraries support NumPy as a very standard interface when you are programming with the libraries in Python. The third thing is NumPy actually gives you a principled representation of data and matrix using what they call the array. So basically, you can think about data, you can think about like the tables of data as 2-dimensional matrices, right? When you are doing the databases, you store the data in the 2-dimensional format. And also, in the machine learning applications, you are extensively playing with like 1-dimensional vectors, 2-dimensional matrix, and even higher dimensional tensors. And all of these things can be represented using this array class in NumPy in a principled way. So just to give a high-level roadmap of what we are going to discuss on NumPy and matplotlib. So basically, I'll go through this list of contents. First, we'll discuss about like how we can construct NumPy arrays, and then we'll discuss about like how after we construct the NumPy array, how you can access the elements and rows and columns in the matrix. After that, I will briefly discuss about like 2 types of math operations over the NumPy array. And after that, I will briefly introduce a functionality of NumPy, which is called broadcasting. And this is a functionality that will be very useful in your following like projects and implementing different machine learning models. At the end, I will give 2 small demos on the module called matplotlib. So matplotlib is a visualization tool on top of NumPy. It basically gives you the functionality to visualize 2D data. And there's also some support for 3D data in this matplotlib. So let's first go through the first step. Like when you open up a Python shell, how can you construct a NumPy array? Basically, first you need to import the NumPy module, as with other different modules in Python. To construct a 1D array from a Python list, you just simply call this array function, and you give the Python list containing the values you want into this function. And the output of this numpy.array function is the NumPy array object. Basically, if you want to try out this online, you can first generate this NumPy array called A, and you can use the print function to print out what is in this A array. Similarly, when you want to construct a 2D array from Python list, you can simply utilize the Python list construction introduced by Mario. Basically, you do a Python list of list, where you have two lists in another list, and then you put it in as the argument into this array function, which generate a 2D NumPy array object. And if you want to look at like what is actually inside this array, you can do print b in your Python shell. Also, besides these fundamental ways to construct NumPy arrays, there are also a lot of like very convenient helper functions. For example, you can use NumPy zeros to generate a matrix filled with zeros. You can also do NumPy ones, and you can also do NumPy .I, which gives you a identity matrix. There are a bunch of these kind of helpers, and you will be learning about them on your trajectory of this course. And basically, after you construct an array, the fundamental question is like, how can you utilize the values inside this NumPy array, which means the entries in the matrices represented by this NumPy array. Here I listed a couple of like very simple ways to access the elements in the matrices. First, if you want to access a specific element in this NumPy array or NumPy matrix, you just simply, for example, here we construct a 2D matrix, and we want to access the element at the intersection of the second row and the third column. Note here, like in Python and in NumPy, the indexing starts from 0. So if you want to index the element at the intersection, you simply put the index of the row and the index of the column after you in the bracket, and you'll be simply able to access the value on that specific entry. So basically, another slightly more advanced way is that how can you access a whole column inside a matrix? For example, the example here access the third column of this matrix. So what we did is that we put a colon and a comma and the index of the column. In this way, you can access the whole column in that matrix. And similarly, you can access a single row of the matrix. Also, to be one step further, how can you use one line to access a range of columns? For example, here, the example gives the syntax of how to access the first and the second column of this matrix. So the 0 colon 2 specifies the range of the columns you want to access. So in the last slides, we discussed about like doing array indexing using integers. Basically, you are specifying the index of columns and rows, and you access the specific entries. Another slightly more advanced way is using Boolean indexing. So what does Boolean indexing do? So it just means like it gives you a flexible way to pick elements under certain conditions. As a concrete example, we construct an array containing 1, 2, 3, and 4. it is a 1D array. And here we are given a condition that we want to access the elements that is larger than 2. So basically, instead of checking which element is larger than 2 manually and give the corresponding index to access the value, you can simply do A larger than 2 as the indexing array. You put it into the bracket and you can access, this will return you the values that are larger than 2. So now we have seen how we can construct a NumPy array, and we have been discussing about how we can access the values entries inside the NumPy array. So now let's discuss a little bit about how we can do math manipulations over these arrays or over these matrices or vectors. So basically, the matrix operations can be decomposed into two categories for NumPy arrays. The first one is the element-wise operation, meaning if you have two matrices with the same shape, you want to perform a specific math operation between the corresponding elements in these two matrices. So here is an example. You construct a 2 by 2 matrix X, and you also construct a 2 by 2 matrix Y. And basically, you want to add them together element-wisely. So basically, you can either do X plus Y, or you can do numpy.add, and you give the two matrices as the argument of this function. So being different from the element-wise operation, another category of the operation is the matrix operations. Like you want to do, say for example, if you want to do matrix multiplication, it's not a element-wise operation anymore. And NumPy provides you convenient interface functions to do these operations like matrix multiplication. For example, you can do x dot y, and you can also do numpy dot x y. These functions help you perform the matrix multiplications. Yes?
Isn't there any way to overload this so you can do star y?
So actually, I would suggest you avoid doing overloading this because the x star y has element-wise meanings. So basically, you will do element-wise multiplication of the matrix entries.
Yes, so we have 3 matrix sometimes each other, then I have to do np dot for the first 2.
Yeah, it's slightly inconvenient, I guess, in your opinion. To be honest, I don't know the specific way to overload the star operator to perform the matrix multiplication, but I will try to dig it out, and later on I can post some information on the Piazza. So basically, one specific functionality of NumPy is called the broadcasting. So what is a broadcasting? It is a powerful mechanism that allows NumPy to work with two arrays which has different shapes when you want to perform some mathematical operations. Basically, in the following example, I will be illustrating you what will happen if you want to play with two matrices with different shapes with and without this broadcasting functionality. And you will see that with the broadcasting functionality, your code would be much simpler, cleaner, and more readable. So as the first example, we want to see without broadcasting, how can we add a vector to each row of a matrix. So for here, X is a two-dimensional matrix where you have 4 rows. And here V is a 1D vector containing 3 elements. So here we want to add vector V to every row of matrix X. Okay, so the naive way to do this is that we just simply loop over the rows of matrix X, and we add this vector to each row of matrix X. Right, so basically you need to do a loop. So now with the broadcasting functionality, this thing can be just in a single line. You construct the 2D matrix X, you construct the one-dimensional vector V, and using a simple line y equals x plus v, you will be able to add the vector V to every row of matrix X. So basically, you can see with the broadcasting functionality, this kind of operation between two matrices with different shapes becomes much cleaner and simpler. And I will later on point you to more reading materials if you want to know more about this broadcasting functionality. Okay, so now is about the matplotlib. So matplotlib is designed to visualize 2D data. Say, for example, you want to plot a curve, and you want to, say, for example, if we want to visualize your predictions as scatter plots. So in these situations, matplotlib is the module that you will want to use. I will do two demos here to show two basic functionalities of matplotlib. So first, I will discuss about the plot function, which will plot a figure or some curves given some NumPy data. The second function I will talk about is the subplot function, which gives you the flexibility to plot multiple figures in the same place. So to do this, I'll do this through the demos. Let's make it larger. Okay, so in this first example, we want to plot a sine curve. So in the code, besides import the NumPy module, you also need to import this module called matplotlib.pyplot. So after you load these two plots, we generate the x data points and the y data points. So what is the x data point? It is an array of numbers with equal intervals from 0 to 3 pi. And what we are going to plot as the y value is the value of the sine function as this discretized point containing in vector x. So basically, the function you would call to plot these data points is called simply just plot. And after you plot the data, you need to call this function called show to make sure the figure will pop up on your screen. So let me just run this demo and you will see. Okay, so after we execute the couple of lines, we will see we are plotting the sine curve in this figure. So in the following assignments, there will be a lot of questions requiring to plot things using matplotlib. Another situation is that you might want to put a couple of figures together for the convenience of readers to understand what is happening. For example, you want to, so basically you have a plotting sheet and you want to divide it into two parts. For the first part, you want to plot the sine curve, and for the second part, you want to plot the cosine curve. So here's an example on the right panel about how to do the subplot. Similarly, we import the NumPy library and the matplotlib library. We generate the discretized points from 0 to 3 pi, and the vector x contains these values. We then generate the y values for the sine function and also generate the values for the cosine function. So now we want to plot two figures in a single place. And the first number specifies that we want 2 rows of figures. And the second number specifies how many columns you want to have in this combined figure. And when you want to plot on the at a specific entry in this array of plots, you will need to use the third number to specify which position you want to plot on. So in our example here, we will first specify that we want to plot in the first position in this combined plots. And we will use the plot function to plot the sine curve. And we will put a title sine to this first plot. And to switch to the other position of this combined plot, we will use the subplot function and specify we want to plot in the second position. And then we plot the cosine curve. After that, we give the title, and then, as usual, we do the show function to visualize the figure we want. Again, let's run this small demo. Okay, so now as you can see here, basically as we want, we have a combined figure where we have 2 rows of plots and 1 column of plots. The first plot the sine curve, while the second plot visualize the cosine curve. And simply, if you want to throw away this plot, just click this. Yes, just one last bit on some suggestions for further learning on NumPy and Matplotlib modules. So basically, the content of this tutorial is borrowed from CS231N. They have more extensive discussions there, and you can also find some IPython notebooks to understand what is happening. And also, when you are using these libraries in the future, personally, I think like Stack Overflow is a good source of solutions. And also, you can get yourself familiar with the documentation of the NumPy and Matplotlibs. There, you can find how to use each function in the NumPy and Matplotlib module. Yeah, that's it for the NumPy and Matplotlib tutorial. Thanks.